Hello everyone. So in this video, we are going to learn how to insert a node in a B plus tree. So I believe you have already uh, understood what is B trees. We have already discussed what is M basis trees, B trees. We have seen the operations of uh, insertion and deletion. So in B tree, basically, when we construct a tree, we see that the node contains the key and record. Both are actually allowed to accommodate in any node. But in the B plus tree, the records are only existing at the leaf node. And internal node are basically storing the keys, and they're also known as the index nodes. And one more difference that you can see in the B plus tree, that in the B plus trees, all the leaf nodes are actually linked together. That will also give us the provision of accessing all the elements in an efficient way. So the idea of making this structure is that if we have a huge amount of data that cannot be accommodated in the main memory, actually we are keeping all the actual data into the hard disk and the index we are keeping into the main memory. So we will see that how the entire thing is to maintain. So let's start. So here you can see this is a B plus tree. See that at the leaf we have 20 and 78. The value you can see at the rightmost leaf, and at the top you can see at that 20 is there. So 20, which is at the internal node, this is basically a key, and the 20 that you see onto the leaf node, it's a record. So all the things that you see on the leaf is actually the record, and what all the things that we see on to the internal node or the root is just a key. So let's see that how this key can be constructed. We'll take one example to understand this in a better way. Because we are going to uh, insert these nodes in a P plus tree of order 3. So we will insert 2. So we have a node, we insert 2. This is our first node that we are going to insert. So actually, the node allows to keep maximum 2 values. So you can keep 2 values at in any node. So we will insert 2 first, and then we have 6. So we insert 6. So 2 is done. Then we insert 6. So 6 is done. Then we insert 10. So 10, if you insert it, because it's an order tree, so it will be going to actually it should come here, but as a property of order tree that any node cannot contain more than two values. So here it is going to split. So we are going to split from the mid value. So this is going to become a mid value. So when we going to split this node, this is basically leaf node at this point in time. So we will also make index of this particular node so that you can access this particular leaf node. So how it is to be done? So we are going to do like this. It's going to be uh, done like this. It is going to be split here, and here we have 6 and 10. And also, this is going to become actually a node, and this also connects to this leaf. Okay, so basically this is here is the key, and this basically refers to the record. So whenever we are going to split any leaf, and it is going to carry the information as a parent, and the parent node is actually containing the key. Okay, so now let's move to the next part. So 10 is done, then 20. So 20 is going to be inserted actually here as per the ordered property rule. So 20 is going to be inserted here, but 20 being inserted, it will violate the order 3 property because we cannot accommodate uh, 3 values here. So we are going to split it, and when we split it, so now we are going to split it. This means 10 is going to be, 10 is going to be going up, and because we are going to split at 10, so the key for 10 is also to be carried at to the upper node. So what does it mean? It means something like this: we have 6, we have 2 here, and then we have 6 here, and then we get 10 here, and then we get 10 and 20. So this is the key, and immediately after the key you can get its record. So key and the next successor element is the record. So this is a 10, and then you get the record 10, 20. So this is how we can get a structure, and also this is going to link together. All the leaves are going to be linked together. 20 is done, and then 78. So 78, so it should be inserted here. So again, this is going to violate the order 3 uh, property. So 20 is going to be going up, means we need to split this. So when I say going up means we are actually going to split, and when we split, so this is going to split like this, and this 20 to be become as a key, and this 20 is kept as a record in this leaf. So what is going to happen? So actually, it will look like this: 6, and then 10, and then 20. So 20 is going to split, and it will become 20, 78, and then we have 10 here, we have a 6 here, and then we have 2 here. But this is not the immediate answer after doing inserting 78, because this is again violating the order 3 property, because here we can see that 3 values are appearing at the node, which is not allowed. So again, we have to split it. Now, this is being record. So whenever you split this, it will carry the key value here. But when you split this itself is a key, it's not record. So there's no need of carrying something, keeping 10 here. For example, if I split from 10, then it does not mean 10 to be kept here and the key will carry it upward. No, because this is just a key. So we are just, fixing it to have a maintained indexing. So we are going to uh, moving up. So what we get finally, we get 10 is coming here, and then we have 6 is here, we have 2 here, and this is 6 here, and then here we have 20, here we have 10, and then we have 20, and 78. So these are all the key values. So you can see that the the successor of this is actually key. You will find the record. Successor of this is a record. Successor of this is a record. So these are all the records, and also they are all linked together. This is one node. This is one node. Okay. So we are done 78. Then we to the 5. So 5 is to be inserted actually directly. So you can just look at this. So 5 to be inserted here. Let me do it here itself. So it becomes 2, 5. And it does not split anything, and everything is maintained. Then 90. So 90 to be inserted here. So when you insert 90, then 78, this this 20, 78, 90 are the record values, and when you are splitting this record then into two part, then 78 need to be, we need to create a key for 78 because this is going to be split here. So we are going to do like this. This is 10, this is 6, this is 2, 5, then we have 6 here, then we have 20 here, we have 10 here, then we have 78 and 78 and 90, and also we have 20 here. So this is what we get after the final insertion. So actually, if you make it into the instead of tree, means this is the root node. This is your internal node, which is actually your index values, and this is your leaf, which is basically your records, and they're also linked to each other. So this is what we get after inserting all these nodes in a B plus tree of order 3. So these are the steps that we have done, and now also we will see all the steps. Let me show you in a more clearer form. So these are the steps that we have gone through. So we have order tree. These are the nodes we started. Then we insert 2, 6, then 10, and then 20, 78, and then 5 and 90. So this is how we have to insert the nodes. Let us take one more example. Okay, so let's look through this example. This is again a B plus tree. We are constructing, and this is given order 3. So we are going to insert 10. Okay, this is 10, and then we insert 9. So order 3 means that every node can have maximum 2 values. Okay, then we insert 9. This is okay, and then we insert 8. So 10 is done, 9 is done. So this is actually the structure of our node, and then we insert 8. So 8 is going to come here, but then this is order 3, so it is going to split. And when we split this node, which is actually a record, then it will also carry its index as a node. So it will look like this. So it will be 9, this is 8, and then we have 9, 10. Okay, then this is done. So 9 is done, 8 is done, then 11. So 11 is going to be inserted here. So when we insert here, so this is going to break, this is going to split this node, which is basically representing a record. So it will go up, and because we are splitting the record, so it will carry its index. So we have 9, we have 8 here, we have 9 here, and then we also get 10 here. So we'll be having 10, 11. Okay, or you can say this 9 should be empty way, should be represented like this. Okay, this is done. So we are done with 11, then we insert 7. The 7 to be inserted here, and this does not require any splitting. Everything is okay. Then we insert 5. So 5 is going to be inserted here, and when we insert 5, this makes this node to be split. So it will be split from here. Actually, when split from here, so actually 7 needs to go up, and it will also create index 7 here and split this into two parts. So how it looks like? It looks like this. So you can see that this is 7, this is 5, this is 7, 8, and then we have 9 here. So you can make it like this. That will be more better form. 9 is here. This is 9, and then we have 10, 10, 11. But then this is also not fulfilling the requirement of order 3. So we are going to again uh, kind of split this node into two parts. But being this being representing a key node, so when it splits, there is no need to carry that index. When we split here, we need to carry the index. So here we can do like this. It becomes like 9, 7, 10. Here we have 5. Here we have 7, 8. Here we have 9. Here we have 10, 11. Okay, so we are done with. Also, you can see the successor value, successor of the key is record. So successor of this key is record. The successor of this key is record. The successor of this key is record. So then 6. So 6 will be insert here. Is okay. Then 26. So 26 is going to be insert here. So when we insert 26 here, so it is going to split this. So 11 is going to move as an index, and it splits into two parts. So what the structure which we get is 9, 7. Here we have 5, 6. Here we have 7, 8, and this is something like this. This is 10, this is 9, and this is now 10, and we split 11 here. So we get 11, 26. So this is how we can get our B plus T so far. So 26 is done. That we so when we uh, insert 3 here, so 3 is going to be inserted here. So it is going to split this. So we will look here. It will become like this. 9. So 5 is going to be going up 5, and it will leave this as a 5, 6, and here we have 3, and here we have 7. This is actually going to become one node. This is one node, and here we have 7, 8. Also, we have not shown here, but actually these nodes are connecting together as a linked list. Okay, so if this is going to be one node, it connects this connect this node, and so on. So let me look here. What is happening here? It's 9, and so we have 10. We have 9 here. We have 10 here, and we have 11, 26 here. And this is all linked. So we are done with 3. I think that last remaining 13. So let's look how 13 will be in. So if we look to this tree, then 13 will be inserted here at this place, right? and being inserted here, it will uh, accommodate three actually values are visible, which is not fulfilling the requirement of order three. So 13 is going to be split. Means 13 will make the node to be split it, and because being a record, it will carry the index. So it will carry the index here, and so we'll get something like this. We get 11 and we get 1326. Let me show you it here. Okay, this is actually being splitted. So now after moving means after splitting, the 11 will remain here. It will move 13 at the here as a parent node, you can say, and 1326 as a child node here. Now this is being again this is node of order 3, which is again having 3, which is not kind of permitted. So we are going to split again, and 11 is going to move up. So finally, what we are going to have? So we are going to have like this. We are having 9, and then also 11 moves there, and then what do you find? At the left we find 5, and you have 7 also here, and the left of 5 is 3. Here you have 5, 6, and here you have 7, 8. Okay, and also you can see here this is going to split. So this is actually in 10 here. So you can see 10 is actually here, and here you can see. Let me do this. Let me get like more. This is 9, and we have 11, and here we have 10, because it will go up. It will split into two parts, and here we have 9, and here we have 10, and at the right of this we have so you can see here we have 13, and then here we have 11, and here we have 13, 26. So we make it like this. This is how our tree will look like. This is our B plus tree. So this is how it looks like after inserting all these nodes. Okay, so we want to see more like the clear form. So I have also already made a kind graphical presentation of output of the B plus tree. Let's have a look at this also. Okay, this is our final tree that we get if inserting all these nodes in a B plus tree of order 3. So I think you have understood how to do insertions. And in the next video, we are going to learn how to do deletion in a B plus. So that's all for this video. Thank you very much.